You came across this question in your chemistry exam. How will you solve it? It is very easy. Now let's solve together. The question says, which of the following is the correct electronic configuration of oxygen? Now, oxygen is an element in chemistry. You can see we are giving a particular information for oxygen. And in the course of solving this question, I'll be explaining to you what this means so we can get the answer to the question without stress. At the end of solving this question, I'm going to give you your own practice question so you solve and provide the answer in the comment section. So ensure you listen carefully to the way I'll be solving this question. Now, from interpretation of this question, what they are simply asking us to do is to write the correct electronic configuration of the element oxygen. And in the course of solving this question, I'm not going to solve for just oxygen. I'll teach you on how to be able to write the correct electronic configuration of all elements in chemistry. So ensure you listen very well. So you can see from the word electronic configuration, wow, I can actually see something. And what is that? If I stop drawing the line up till this part, you see that from this alone, electronic, I can bring out a very key concept in chemistry called electron. Remember, electron is one part of an atom. An atom basically is the smallest way any element can exist in simple terms. You know, atom is simply the smallest particle of an element that can take part in a chemical reaction. So inside that atom, we have various components, and one of them is electron. So you can see from the word electronic, for we to be able to understand properly on how to write electronic configuration of elements, we have to basically understand the chemistry of electrons, all right? So please listen very well. So what I've said here is that an atom basically is divided into three subatomic particles, which I call them pen. I call them what? Pen, which are protons, electrons, and neutrons, all right? So we are interested in electron in the course of learning on how to write electronic configuration of any element. So please listen very well. So moving further, to be able to write electronic configuration of elements, you have to know some rules or some principle. And one of the key principles you have to take note of here in the course of writing electronic configuration of elements, not just oxygen in this case, that rule you must understand is what we call the Aufbau's principle. What did I say? It is called what? The Aufbau principle. Now, Aufbau principle has another name. We can also call it the build-up principle. Now, the question you ask yourself, what does this principle actually state? Now, just state it, but then I will explain to you what you need to know to be able to solve this question. Now, Aufbau principle states that electrons, you can see the word electrons, you can see the word electrons should occupy orbitals of lower energy before those of higher energy. Now, let me explain to you what this means. Remember, I said that the Aufbau principle is a principle, all right, and it's also called the build-up principle. Now, it has a chart. Please listen. Please listen very well. In chemistry, we have various orbitals. Because I just explained to you that on Aufbau principle, it said that electrons should occupy orbitals of lower energy, all right? So in chemistry, we have various orbitals. So the question you ask yourself, what are these orbitals we have in chemistry? These orbitals include the s orbital, the p orbital, the d, and the f orbital. Please listen very well, all right? You can see I said that the s orbital, all right, the p orbital, the d orbital, and the f orbital. Though we have other orbitals, but for basic understanding of the concept, you have to note these orbitals. So for the Aufbau principle, here is the chart you must master. Please listen very well. So you start writing from 1s, just follow me. The first orbital is s orbital. So we simply write 1s first, 2s, 3s, 4s, 5s, 6s, and 7s. We'll stop here. Now we'll go back to the p orbital. We write for the p orbital as well. You writing for the p orbital, you start from number 2. Please listen. I'm teaching you on how it works so that you can be able to generate the charts, the Aufbau principle chart, to be able to solve questions under this aspect. So please listen very well. You can say I said we start from 2 for the p. So 2p, all right, 3p, 4p, 5p, 6p, and 7p. So moving further, we'll go back to D orbital, all right, and we'll start from the next number, which is 3 in this case. So 3D, not in this case, in all cases, all right. So 3D, 4D, 5D, 6D, and 7D. Are you there? So after that, we'll go back to the F orbital. In this case, the last orbital. We'll start from the next number, which is 4F, all right, 5F, and 6F, and 7F. You can see what we have done. So moving further, this is what we'll do next. Please listen very well. We'll start drawing a line from top to bottom. For the first one, I'll draw a line like this across it. You can see the line. For this, for 1S, please just follow me. For 2S, I'll do the same. I'll draw a line from top to bottom, diagonally. Are you there? Please just listen, follow me. From 2P to 3S, I'll do another thing like that. Are you see what's happening? From this to this, you can see the way I'm drawing the line, oh, and you can see the way the line is coming down, the direction to which the line is coming down. Because this format, is this thing I'm doing now that'll be able to make us understand how to write electronic configuration of elements. Please listen very well. This is very, very easy. I have to explain to you properly so you can be able to solve questions when you see them in your exams. So moving further, these orbitals I have mentioned, orbitals has their meaning as well. Orbitals are regions in space where electrons are likely to be seen. That's what we call orbitals. So these orbitals, they have maximum number of electrons that they can occupy. Listen, for S orbital, the maximum number of electrons that will occupy the S orbital is 2 electrons, though there is a reason. And I've done it on my video lesson on my YouTube channel, which is on the topic quantum number. All right, you see the video here on the screen. So after watching this video, ensure you go watch that lesson on quantum number so as to understand properly all of this concept. I've done them on my YouTube channel. So S orbital is 2 electrons. It occupies a maximum. So the maximum number of electrons that will occupy the p orbital is 6 electrons. There is a reason as well. I know the reason. I've done it on my channel, so go watch that lesson. For the d orbital, the maximum number of electrons is 10 electrons that can occupy the d orbital. And lastly, for the f orbital is 14 electrons that will occupy the f orbital in maximum. So guys, moving further, what do we do next? Remember, we are writing the electronic configuration of oxygen as an element. Then I wrote something in brackets, Z is equal to 8. What does that mean? Actually, Z here simply means atomic number. And please take note of this, all right? For atoms that are neutral, atoms, elements, okay, let me not use atom now. For elements that are neutral, so you understand properly, elements that are neutral, that means this element does not have a charge. Your atomic number is normally same as your proton number in chemistry. But for elements that are neutral, that doesn't have a charge, since I told you guys that this Z means atomic number, actually, an atomic number is also called proton number. And for elements that are neutral, proton number is always equal to electron number. And I told you, for you to be able to write electronic configuration, you use electron. So Z being 8, being the proton number, I've done it on my channel. I've explained it properly. So go and watch those lessons. Z here is the atomic number of oxygen. Z, that's what it's called. Z is the atomic number of oxygen, and atomic number is also called proton number. Note that two informations. And for elements that are neutral, because oxygen standing here is neutral, did not tell me that it was charged. So this oxygen is neutral. So take note, proton number and electron number for a neutral atom are the same. So since Z is atomic number, and atomic number is also called proton number, so proton number is 8. What becomes the electron number for oxygen as well? 8, because oxygen is neutral in this case. But that's why they gave us this information. You don't have to stress yourself. They gave you this information so as to note here that, okay, oh, this is what you need to actually write the electronic configuration. Because take note, electronic, you need electron, nothing else. Do you understand? Because there are other diverse which questions come, and they are all very easy. I've explained them on my channel. So go and watch all the lessons on my channel so as to understand key concepts in chemistry across all topics. All right. So this Z equals 8 is the electron number. Yes, it is the electron number. So here's the electron number. So writing the electronic configuration, EC will now be what? All right, let's start. You can see the line starts from this 1s coming from top to bottom, because we write from top to bottom. Top to bottom. So 1s, I'll write it. 1s. Now for s orbital, what's the maximum number of electrons it occupies? It is 2 electrons. So here become 1s2. Are you there? So moving further, what do we do next? After 1s, what's the next? It is 2s now. Can I just come here to 2p and no, it's 2s that is the next. So I'll write 2x. Remember I said it's top to bottom. So we are done with this. We'll still come here top to bottom as well. So 2s. So 2s is still s orbital. How many? What's the maximum number of electrons for the s orbital? Is still 2. You understand? So after 2s, what's the next? Should you come here? No, don't do that. Start from up now. I told you it's top to bottom. So you are coming like this. You are coming from top to bottom. So the next is 2p. Remember, we are trying to write for 8. Remember now, moving further, 2p. So p orbital, how many was the maximum number of electrons it occupies? 6. So then if we write 6, what then happens? Relax. Remember, we're trying to write for 8. So you now calculate first. So 2 plus 2, that's 4. 4 plus 6, that's 10. And it has exceeded, what we need, which is 8. So you can just change it to 4. Do you understand? I believe you understand what is happening. They're all very easy because it was now more than, the normal, which is 8 we are looking for. In this case, it was not 10 initially. No, we must ensure that you remove from that last orbital you've written 2p4 now in this case. Because when you count, because you're writing for 8 being the electron number. So 2 plus 2, that's 4. 4 plus 4, that's 8. This is the electronic configuration of oxygen. So you look at the answer. Look for your answer in the option. Option A is the answer to this question. They are all very easy. They are not difficult at all. So that's how it's solved. So I'll be giving you a practice question so you solve and provide the answer in the comment section. All right. So you write the electronic configuration for various elements for me. Nitrogen, you write for nitrogen for me. You write for chlorine. All right. Also, you write for neon, all right? Neon as an element. I'll tell you their electron number. To get the electron number, just to count all the elements. All right, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. Nitrogen, oxygen. So nitrogen is number 7. So Z will not be equal to 7 in this case. Nitrogen, oxygen. Okay, this chlorine now. What number is chlorine in the periodic table? So these are your practice questions. Ensure you solve the questions and provide the answer in the comment section. If you find my video lesson helpful, make sure you click on the subscribe button to my channel and also share with your friends. Thanks for watching.